Hello, now we are moving to the second topic of op-amp in nonlinear region, which is the Schmitt trigger. Hopefully at the end of this topic, students should be able to derive the output equation of a Schmitt trigger, describe the operation of Schmitt trigger, and also design a Schmitt trigger circuit. Schmitt trigger is actually a comparator with memory. It exhibits hysteresis. Hysteresis is defined as the difference between two trigger levels. We have V hysteresis or simply VH, which is the difference between the V upper threshold point and V lower threshold point. So the difference between these two threshold voltages will give you VH or V hysteresis. This is the circuit of a Schmitt trigger. It simply has two resistors, R1, R2. We connect the op-amp to the power supply plus VCC minus VCC, and the input voltage is coming to the negative terminal. So this input voltage terminal will be compared with the voltage at the positive terminal. Okay, we call it V plus, and this V plus is actually the same voltage between R1 and R2, or simply it is actually the voltage across R2. And this value, V plus, can be either positive or negative depending on the value of your output voltage here. If the output voltage is plus VCC or plus VO max, V plus will be the upper threshold point, but if the output voltage is minus VCC or minus VO set, this V plus will be a V lower threshold point voltage. So next, we analyze the circuit of Schmitt trigger. This is a positive feedback arrangement. So we look at the negative switching first. When the output at the positive voltage, maximum output voltage is positive, it is plus VCC or we call it plus V out max. Your V plus will be V upper threshold point, and we can determine the upper threshold point, which is the voltage across R2, using a voltage divider, which is VO multiplied with R2 over the total resistance. So we call this as V upper threshold point. Your input is a sinusoidal waveform. So this sinusoidal waveform is being compared with the upper threshold point. As long as your input voltage is lower than upper threshold point, or we say that the upper threshold point is greater than the V input, since the upper threshold point is coming to the positive terminal of your op-amp, your output will stay at the positive output maximum. Okay, so you still have a plus VO max, which is equal more or less to the plus VCC. And when the output is positive, we call this is upper threshold point, and we are comparing your Vin, and Vin is increasing, and once the Vin is greater than upper threshold point, okay, which is right here, okay, it is greater than upper threshold point, Vin is into the negative terminal. So at this point, after the upper threshold point, when Vin greater than upper threshold point, your output will go to negative V out max or negative VCC. So it will switch, and this output, which is minus VO max, making the upper threshold becomes a lower threshold point. So now, once your output becomes negative V out max, what will happen? We'll have a positive switching. So your V out at negative value, your V plus now is called V lower threshold point. Okay, and this lower threshold point is the voltage across R2. So using a voltage divider, we have VO multiplied with R2 divided by total resistance R1, R2. Only that the V out now is negative V out max. So now your input after your output becomes negative, we are comparing the input to the lower threshold point. As long as your input is greater than the lower threshold point, your output will stay at the V out max. Nothing will change at the output because your input is greater than lower threshold. Vin coming to the negative terminal, so output stays at negative value. But once your input is less than the lower threshold point, which is here, okay, so we say that V lower threshold point greater than Vin. V lower threshold comes into the positive terminal, so your output will go positive V out max. And if the V out becomes plus V out max, this positive terminal will become V upper threshold point, which is the previous slide, and this thing will continue as long as you have an input Vi over here. This is the Schmitt trigger circuit. You have a sinusoidal waveform, which is your input coming into the negative terminal, and this input is being compared with the upper threshold point when V out is plus VCC or plus V out max, and as long as your V in is less than upper threshold point or V upper threshold point greater, V upper threshold point is coming into the positive terminal, your output will stay at positive. Once it is greater, your input is greater, your output will go to a negative value. When it is a negative value, this node will become lower threshold point. So your input right now being compared with a V lower threshold point. As long as it is greater than the lower threshold point, your output stays at negative V out max or negative VCC. And right here, this is the transition point, and after this node, your V in will be less compared to the V lower threshold point, or we say that V lower threshold point is greater than V in. V lower threshold coming into the positive terminal, so your output will go positive again. And when the output is positive, now we are comparing V in with the upper threshold point. So this is how the output of a Schmitt trigger, which is a square wave over here. So meaning that from a sinusoidal waveform coming into the input of Schmitt trigger, at the output you'll get a square wave. So we can say that the Schmitt trigger will produce a square wave, or we say that it is a waveform changer from a sinusoidal waveform to a square wave. And just now, when you look at the upper threshold point and lower threshold point voltage, one is positive and the other one is negative, because V out can be plus VCC or minus VCC. So when we draw the transfer characteristic of Schmitt trigger, we have positive upper threshold point voltage and a negative lower threshold point. And your V in is being compared whether with upper threshold or lower threshold point. The output can be a positive VSAT or positive VO max or plus VCC, and it could be minus VSAT or negative VCC. This is an example of a sinusoidal waveform corrupted with a noise, and this is the voltage input to the negative terminal. So again, this input voltage will be compared with the upper threshold point and the lower threshold point. As long as your V in less than upper threshold point or V upper threshold is greater than V in, V upper threshold is to the positive terminal, so your output will stay at positive. When V in greater, the output will go negative. As long as the input is greater than lower threshold, now we are comparing with a lower threshold because the output is negative. So meaning that this node is lower threshold point. So we are comparing V in with the lower threshold point. As long as it is greater, your V out will stay negative because the input is coming to the negative terminal. And once your V in is less than lower threshold point, your output will go positive again. So here, what is shown is that the Schmitt trigger will provide a noise immunity. Even though there is a noise in the signal, there is no false triggering, unlike the comparator that we have learned before this. Because we are comparing the input voltage with two values, which is the upper threshold point and the lower threshold point. So the voltage between upper and lower threshold point is V hysteresis, and this sometimes is called as a dead zone. So this is an example right here. This is your input. Your V in is less than upper threshold is greater, the output is positive. So right here, your V in is greater, right? When V in is greater, the output goes negative. But if you look over here, there is a slight time your input V in is less than V upper threshold. But there is no false triggering here because we are not comparing the input with the upper threshold, because this input will be compared with the V lower threshold point. Okay, so that's why we didn't get a false triggering right here. For comparator, we have looked that we are only comparing the signal with just one reference voltage. But now we have two, V upper and V lower threshold point. Unless this signal with a noise which is a very large noise which is crossing the V hysteresis, which is crossing the difference between upper threshold and the lower threshold point, then only you will get a false triggering over here. But it is unlikely to have a noise with such amplitude, meaning that usually we'll know that what is the amplitude of the noise, so we can choose the right value of R1, R2 to choose the suitable value for V upper threshold and V lower threshold point. So this can be avoided because V hysteresis right here usually is very large. This is another example of a Schmitt trigger, but this particular node, before this node is grounded. So our V upper threshold point and V lower threshold point, one is positive and one is negative. But if we put this node to a reference voltage, Vref, we can make the V upper threshold or V lower threshold to either both positive or both negative. And using a voltage divider and superposition theorem, the value of V plus over here is actually this. Vref multiplied with R1 divided by the total resistance plus VO multiplied with R2 divided by R1 plus R2. So it is cross. Vref multiplied with R1, VO multiplied with R2. Okay, so this is the voltage at the positive terminal, and this can be both positive or both negative. Your VO can be plus VCC or plus VO max, or negative VCC or negative VO max. The upper threshold point, in this case, my VO is plus VCC. So it could be a positive value, and the lower threshold point is the V out is equals to minus VCC or minus V sat or minus VO saturation. So you can choose the right value of R1, R2. So your upper threshold point and the V lower threshold point can be both positive. Okay, and you can also have both the lower and the upper threshold point be a negative value. So you should choose the right value of R1 and R2. So this is about a Schmitt trigger. A Schmitt trigger provides a noise immunity unlike a comparator. So Schmitt trigger is a better circuit compared to the comparator. You should be able to determine the output of a Schmitt trigger. The output will be a square wave by comparing the input with two threshold voltage, which is V upper threshold point and V lower threshold. Thank you.